Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring an algebraic expression called the discriminant of a quadratic equation. Now, the discriminant is important because if we know the discriminant, we know what type, how many solutions a quadratic equation will have, and what type of solutions they are. It also helps us to know which method will be easiest to use when we solve the equation. Now, the discriminant is simply an expression that comes from the quadratic formula, and it's just the part that's under the square root symbol, so the b squared minus 4ac. Now, your discriminant, when you calculate it, it's either going to be a positive number, a negative number, or it's going to be zero. One of those three things can happen. And those three things will tell us what type of solutions we're going to have. So in problem 1, we have x squared plus 2x minus 8. In order to calculate the discriminant, we need to know the value of a, the value of b, and the value of c. So our a value is 1, our b value is 2, our c value is negative 8. So when you calculate the discriminant, you write down the formula, which is b squared minus 4 times a times c, then replace all of your variables with parentheses, and then plug in your values. So b is 2, a is 1, c is negative 8. All right. Now, I generally use my calculator to prevent, because some of these numbers get really big. You can also do this by hand. Obviously, using your calculator takes a little bit longer. So we have 2 squared minus 4 times 1 times negative 8, and we get 36. Hopefully you noticed that I made a little mistake here. I forgot the square on there, but I did use the square when I put it into my calculator. So our the value of our discriminant in this problem is positive 36. That's one of the three things that can happen. Now, whenever that discriminant is a positive, perfect square, that means you can solve it by factoring. So that's what we're going to do in this problem. I'm going to take my original problem, x squared plus 2x minus 8 equals 0. I'll draw two parentheses. I'll use x and x for 8. I'm going to use 4 and 2. I'll put the positive on the 4, the negative on the 2. So that gives me solutions of negative 4 and positive 2. Now, in the fourth column, they want you to tell the number, how many solutions were there, and what type are they? Are they real numbers or complex numbers? So here we had 2, and they're real number solutions. Now, I also want you to get used to seeing what the graph of a function that has a positive square root is going to look like. So we have x squared plus 2x minus 8. And you can see it has a 0 at negative 4 and a 0 at positive 2. So in this last column, they just want you to make a rough sketch. Please don't do anything fancy here. Just all I want you to do is make a rough sketch. You don't really have to label this, but put one of your zeros there at negative 4, put your other 0 at positive 2, and then for the rest, just kind of make sure it opens up. But again, nothing fancy. We're not plotting a bunch of points. Just what I want you to notice mainly to pay attention to is that our two zeros are the same as our solutions. Okay. In our next problem, we have x squared plus 6x plus 9. So our value of a is 1, b is 6, c is 9. To calculate the value of the discriminant, I'm going to use the same expression, b squared minus 4 times a times c. I'll use parentheses here. And I'll plug in a 6 for the b, 1 for the a, 9 for the c. I'm just going to come over here and replace that 2 with a 6, The 1 can stay, but the -8 needs to become a 9. And that gives me a discriminant of 0. That's another possibility when you calculate discriminant. Sometimes you're going to get 0. All right, now in this problem, we could actually solve this one by factoring because 0 is a perfect square, but they want us to solve it by completing the square. So what I'm going to do, when we complete the square, remember we want to keep the variable terms on the left side, and we want to move the constants to the other side. Okay, then we're going to find the number that completes the square and add that number to both sides. So half of 6 is 3, 3 squared is 9, so I'm adding a 9 to both sides. Now I want to factor the left side, so this would be x plus 3 parentheses squared, and -9 plus 9 is 0. Now take your square root of both sides, so x plus 3. Now normally we would put plus or minus here, but 0 can't be positive or negative, so we're just going to put 0, and then move the 3 to the other side to get x equals -3. So notice in this problem, we only had one solution, and it is a real number. It's a negative number, but it's a real number. So we had one real number solution. Now let's look at what that looks like. Let me change that to a 6 and change that -8 to +9. All right, so here's what I want you to notice. This problem touched the x-axis one time at -3. So again, I'll make me a real rough sketch. Here's my 0 is at -3. That's the only solution we have, and it opens up. A lot of students think if the discriminant is 0, that means they're going to have no solutions. But when the discriminant is 0, it means you're always going to have one solution. Okay. All right, next problem. I'd like you to pause the video and find the discriminant on your own for this problem. All right, welcome back. Hopefully you were able to find the discriminant here. The value of B was 3, the value of A was 1, the value of C was 5. When I put that in my calculator, I got 3 squared minus 4 times 1 times 5, and I got -11. All right, when our discriminant is negative, that means we're going to have to use either the quadratic formula or completing the square. In this problem, I would not use completing the square because that middle term is an odd number. I would definitely use quadratic formula on this problem. So the nice thing about using the quadratic formula is you already know what number goes under the square root. So in quadratic formula, I'm going to take the opposite of b, which is -3, plus or minus the square root. We already know this value is going to be -11 all over 2 times a, which in this problem is 1. Now, if we simplify that, the square root of -11 is the same thing as square root -1 times square root +11, which would be I times square root 11. So to simplify this, -3 plus or minus I square root 11 over 2. Now, because we use the imaginary unit, that means our solutions are not real numbers, they're complex numbers. And because there's a plus or minus, that means there are 2 of them. So we have 2 complex number solutions. Just abbreviate that. Now, what does it look like when we have 2 complex solutions? So let's graph this. Let's change this 6 to a 3 and change this 9 to a 5. Now, notice when your solutions are complex, that means your graph will never touch the x-axis. So let's make a little rough sketch of this. Here's our vertex. Looks something like that. All right, now let's summarize here. When our discriminant was positive, we had 2 real number solutions. When our discriminant was 0, we had 1 real number solution. And when our discriminant is negative, there are 2 complex solutions, and it will never touch the x-axis. Okay? Now, on the next page, we're going to look at how to use the discriminant to not only determine the number and type of solutions, but to give us a hint into which solving method we should use. Okay? Now, before we start, I just want to reiterate that the quadratic formula can be used to solve any quadratic equation, but it's not always the easiest method. That's what we're going to kind of look at today. How do you make your work a little bit easier? All right. So, discriminant summary. If b squared minus 4ac, if the discriminant is greater than 0 or positive, that simply means there'll be 2 real number solutions and there will be 2 x-intercepts. But if the discriminant is a perfect square, we know that the equation is factorable. Now, if you don't like factoring, that's okay. Use the quadratic formula. But it is nice to know if something's factorable, because sometimes it's a lot faster than using the quadratic formula or completing the square. All right? Now, if your discriminant is equal to 0, what that means is there's only going to be 1 real number solution and 1 x-intercept. The equation is, if the discriminant is 0, will always be factorable, because 0 is a perfect square. It's always factorable. Again, if you don't like factoring, go back to quadratic formula. Doesn't matter, okay? If your discriminant is less than 0, if it's negative, that means your solutions are going to be complex numbers. And there will be 0 x-intercepts, okay? And the equation is not factorable, even if that negative is a perfect square. So say I got a discriminant of negative 25. That's a perfect square, but because of that negative, that means you're not going to be able to factor it. That means your solutions are complex numbers. Okay, so you're going to solve these type of problems using either the quadratic formula or completing the square. However, quadratic formula will always be easier if b is an odd number or if the a value is greater than 1. Okay, so quadratic formula is usually my default. All right. Now, let's look at a couple examples of these. For each of the following, determine the discriminant, the number and type of solutions, and then choose whether to solve by factoring, completing the square, or quadratic formula. So, in problem A, before we can calculate the discriminant, we need to rewrite this in standard form. So 6x squared minus x minus 2 equals 0. Now we can calculate our discriminant using the formula b squared minus 4 times a times c. Okay, let me replace my variables here with parentheses. I'm going to plug in a -1 for the b, a 6 for the a, and a -2 for the c. So let me just change these numbers I already have in here. -1, a in this problem is 6, and c in this problem is -2. So I'm getting a discriminant of 49, which is a perfect square, which means it is factorable. We can solve it by factoring. So since we can solve this one by factoring, I'll go ahead and do that. I'll do my 2, but if you want to solve by quadratic formula, feel free. For 6x squared, I'll use 2x and 3x. For the 2, I'm going to use 1 times 2. Now I want this middle value to be -1. So I want the negative to be here. So that means my solutions here are negative 1/2 and positive 2/3. Now, a good way to check that is to graph your equation. Let's see here. 6x squared minus x. So let me change this to minus x, and then what was it? Minus 2 minus 2, and then I can check negative 1/2, yes. 0.667 is equivalent to 2/3, so that means I solved it correctly. So there are our two real number solutions. And I do believe that it asked us to state that, so I'm going to write that down. Two real number solutions. I forgot that part. Okay. All right, problem B. We have negative x squared plus 4x minus 11 equals 0. So it's already in standard form. So I'm going to calculate my discriminant here. I'm going to plug in a 4 for the B, a negative 1 for the A, and a negative 11 for the C. So let's just edit these numbers here. This will be 4. The 6 will change to a negative 1. And the negative 2 will change to negative 11. Now I'm getting a discriminant of negative 28. Now, when our discriminant is negative, that means there'll be two complex number solutions. Okay. Now, to solve this one, I can use completing the square or quadratic formula. I think I'll use completing the square on this one, simply because I want you to see what it's going to look like with each method. Now, so to solve by completing the square, I don't want the value of a to be negative 1, so I'm going to multiply everything in here by negative 1. So that would become positive x squared minus 4x plus 11 equals 0. Now it'll be easier to solve by completing the square. So for completing the square, I want to move that 11 to the other side. And then I'm going to find the number that will complete the square and add that to both sides. So half of 4 is 2. 2 squared is 4, so I'll put a 4 there and there. Okay. And then factor it. This would be x minus 2 parentheses squared. Over here we would have negative 8. All right, take the square root of both sides. So this would be x minus 2. Now, to simplify square root of negative 8, let's just do a reminder here. This would be square root negative 1 times square root 4 times square root 2. So the square root of negative 1 is I. The square root of 4 is 2. Square root of 2 will not simplify. So I'm going to rewrite that as 2i square root 2. So over here, x minus 2 equals plus or minus 2i square root 2. Now, add 2 to both sides. So I would get 2 plus or minus 2i square root 2. All right, problem C. We have x squared plus 5x minus 12 equals 0. We're going to start by getting our discriminant. So I'm going to plug in a 5 for the B, a 1 for the A, and a negative 12 for the C. So I'll come over here, I'll edit this, change the 4 to a 5, change that negative 1 to positive 1, and change that negative 11 to negative 12. That gives me a discriminant of 73. That means it's going to be two real solutions. Now, 73 is not a perfect square. That means this is not factorable. We can't solve it by factoring. Not factorable. So we have to use completing the square or quadratic formula. Now, I would personally not use completing the square because there's an odd number as your B term. And if there's an odd number as your B term, it's much easier to use the quadratic formula. Now, when we use the quadratic formula, we'll take opposite of B, so negative 5, plus or minus the square root of B squared minus 4AC, which we already know is 73, all over 2 times 1, which is 2. Now, to simplify this, well, 73 will not break down, so I'm just going to leave it like this. Now, let me show you what this one looks like, what the graph looks like. We have x squared plus 5x, and then minus 12. All right, so you can see I have one solution here at negative 6.772. So if I were to write the solution in decimal form, it would be approximately negative 6.8. And then I have another solution here at approximately 1.8. Generally, you're going to be asked for exact answers, but if you're ever asked for a decimal approximation, you've got it. Okay, but notice, what I want you to notice are there are two x-intercepts, which means there are two real number solutions. All right. Problem D, 4x squared minus 12x equals negative 9. Now, to find the discriminant, I need to put this in standard form, so I'll need to add 9 to both sides. Now we can do our discriminant. I will plug in a negative 12 for the B, a 4 for the A, a 9 for the C. So let's see, negative 12, 4 times 4, and 9. Parenthesis. And that means our discriminant is, whoops, I didn't mean to do that. Our discriminant is 0. And if our discriminant is 0, which I need to put it over here, I'm so sorry. If the discriminant is 0, that means you'll have one real number solution. And 0 is a perfect square, so that tells me this is factorable. 0 will always be a perfect square. So let's factor this. Now, if you notice, this is a perfect square trinomial. So to factor a perfect square trinomial, I just take the square root of the first term, 2x times 2x, and the square root of the last term, square root of 9 is 3. I'm sorry, that was supposed to be positive 9, and make them both negative. All right, so to solve this, I'm going to have one solution. So I'll just set 2x minus 3 equals 0 and solve for x. So x would be 3 over 2. All right, now let me just show you what the graph of this looks like. Let's change this to 4x squared minus 12x, and then plus 9. So notice we have one solution right there at 1.5, which is equivalent to 3 over 2. And that concludes today's lesson on the discriminant of a quadratic equation.